of tiny particles called the atoms. The atoms are not the smallest particles in matter. However, they are the fundamental units that can take part in a chemical reaction. But they're also made of smaller particles, and there are many small particles. But now we're going to be referring only to protons, electrons, and neutrons. These particles, they have so little mass, and we can use something that is called the relative atomic mass or atomic mass units as well. Sometimes you can see it like this one, atomic mass units, MAU, in order to identify the mass of these substances. When we have this relative atomic mass, we need to distinguish which ones is heavier and which ones they have more or less the same mass. This table is very important when we just describe the atom, and that's a table that you need to be very familiar with, because it's very likely that you're going to see it like in multiple questions. When we had the subatomic particle, we had the proton, the relative mass is 1. This is not the actual mass. The actual mass is in kilograms, but it's relative mass. So that means that when we say relative mass of a proton and relative mass of a neutron, that is 1, we're saying that they have the same mass. In advanced chemistry courses, you're going to see the exact mass of these ones, and you will see that in reality the neutron has a slighter heavier mass. But then in terms of relative mass, we say that they all have relative mass, 1 atomic mass unit and 1 atomic mass unit. The proton, they have a positive charge, and we represent this with a positive +1, and this is located in the nucleus. The neutron, as well, relative mass 1, has no charge, it is neutral, and it is also in the nucleus. And the electron is almost 1/2000 the mass of the other particles, the proton or the neutron, and essentially 0. We said that the mass of the electron is negligible. So whenever we consider the mass of an atom, we're talking about the proton and the neutron, and we're not considering the electrons. The charge of the electrons is -1, and the overall charge of an atom is given by the number of protons and the number of electrons. If the number of protons equals the number of electrons, then the atom is neutral, and the electrons are located outside the electron clouds. So here we can see in this animation again, these particles floating around are the electrons, and inside we have the nucleus, and that's where we have protons and neutrons. Remember that we have many more subatomic particles, but in general, for this course, we're going to be talking only about these 3 subatomic particles. So this is what we have. So the nucleus is protons plus neutrons. So this is also known as the atomic mass. So the mass of an atom is given by the addition of protons and neutrons. And remember that the electrons, they're negatively charged, and they are located outside the nucleus in different energy levels. We're going to see about the energy levels later on. This is important takeaways from this section. So the number of neutrons in an atom tells you which element it belongs to. Change the number of protons, you change the element. This is also known as the atomic number. These are at the atomic number in the periodic table, okay? And it's represented by the letter Z. That is the atomic number, the number of protons, and it's unique for every single atom. So that's why when we say, if you know the number of protons in an atom, then you also know the number of electrons. They're equal, but only if the atom is neutral. Because sometimes you may have, when you change the electrons, okay, this is as well something that you need to remember. Changing the electrons changes charge and produces what we call ions. This is a very important concept as well in chemistry, the concept of ions, because ions are particles with charge, and it's basically due to the change in the number of electrons, because when you change the protons, you change the element. So protons and neutrons from the nucleus form a nucleus in the center of the atom, and they are called nucleus. And the addition of both, okay, the addition of protons and neutrons is equal to what we call the atomic mass. And we're going to be using atomic mass units in order to do this one. So the electrons circle the nucleus very fast with different energy levels, and they are called shells as well, energy levels. For this course, we're going to see later on, we will be discussing only up to 4 shells, okay? But this is just for the exam that you take in 10th grade. Eventually, you're gonna see that there are many more, and we're gonna discuss, the multiple energy levels. As we said, the electrons have negligible mass, so the atomic mass is due to the nucleus.